We're doing this because we're just searching for how the universe works. Astronomy is an observational science. It's like a detective game. I can't touch the object. All I can do is gather the light from it. And then we use physics to tease out actually amazingly large amounts of information from just this faint light that we gather.
It's a star with a shorter lifetime, therefore it's more likely to be a younger star if you just were to find it.
Most people want to know where we came from and where we're going, and astronomy is part of the way that we can answer those questions.
We have been in the business of enjoying and exploring the natural world with the telescopes for nearly the whole 150-year history of Carleton. We have an excellent track record of engaging both men and women in our program, and while we study the stars and galaxies and try to understand the fate of the universe, we also pay close attention to developing a good sense of community and enjoy learning with each other.
That one right there, straight ahead.
Yeah.
Or do you want to take a look?
Oh. All right, I see Jupiter and 2 moons.
I've taken a large number of students to the telescope in Puerto Rico, the largest radio telescope in the world. It's 1,000 feet across. You can go up to this 6-story tall building that's hanging up there where all the radio waves are gathered.
It was definitely one of the best times of my life. I mean, it was absolutely mesmerizing. When I came here, I knew that I had a general interest in physics, so I took an introductory course that really found, how interesting the field of astrophysics and how challenging it is, and I feel like I wanted to pursue this field.
You like challenging?
Yeah, that's why I work with you.
He's a complete collaborator, and we're within a few days of submitting what I think is an important paper, studying Einstein's theory of general relativity using a pulsar that's orbiting another star. It's one of the best places to test Einstein's theory.
So shown here are the parameters responsible for a general relativistic effect called Shapiro delay. So it's basically the delay of transmission of light when the pulsar, which is emitter, moves behind another massive object, which would cause the space-time surface to bend. Hence, the light would travel extra distance and it will take longer to arrive at the Earth. So the difference is at most, 50 microseconds, which is 1/1,000,000th of a second. It's really exciting, and I'm honored to have my names on the paper that's going to be published. But on the other hand, it really means responsibility that you have to get your things right, and that's the scary part, because I'm not sure if I got everything right. But with Joe, we sort of went over it again and confirmed that what I did was indeed correct, so now I'm very much more confident about it. So my favorite part about working with Joe is it's just how great the supervisor is, that he's always working with you and he's always there when you run into trouble, and that he treats you as a fair collaborator and always acknowledge what you have done. And I think that's really empowering for, junior scientists like me.
This is a golden age of astronomy. There's so many exciting discoveries, and so much of what happens in the universe stretches the imagination almost to the breaking point. It was discovered about 100 years ago that the whole universe is expanding, and that's amazing enough. But then just a few decades ago, it was discovered that the expansion is accelerating, and that goes against pretty much everything that we imagined. We thought it would, if anything, be slowing down, and we still don't understand why that is. So some observations are leading to profound questions and hopefully eventually some answers about the deep nature of the universe.